All right. I think that's where we were.
Yeah.
And storing forward. So which of the following techniques is used by digital satellites to relay messages? Bravo. What's the purpose of digital store and forward functions on an amateur radio satellite? Faraday rotation, because satellites typically rotate. Your or and they also typically use a circularly polarized antenna anyway. But you get this called spin fading or spin modulation as it rotates, depending on the antenna. And also the polarization changes. I always thought it was due to uh, the propagation effects from refraction, but this also says the magnetic field affects the polarization.
Yeah, as it goes through magnetic fields, it gets rotating in the atmosphere.
And they call that Faraday rotation because Faraday had stuff to do with magnetic fields and E fields also. So most of the satellite antennas that you use are going to be circularly polarized to account for the fact that your signal is not only physically rotating, but it's electrically rotating in phase. So what type of antenna can be used to minimize the effects of spin modulation and Faraday rotation? Huh?
It's all dipole array.
Well, if you could keep it synchronized.
Put that on. It's off here.
Okay, so we talked about Keplerian elements or the parameters that define the orbits. LEO satellites, typically polar orbits, either ascending or descending, depending on what's going south to north, north to south. Geostationary satellites, of which there's now an amateur one, is in one position. We just don't know where it is, but we could look it up. I assume since it's an amateur US satellite, it's probably located over the Midwest, would be my guess. So you could see it from anywhere. We talked about, go ahead. We talked about satellite modes representing uplink, downlink frequency bands of whether it's UHF, VHF, or VHF, UHF. What the L band and S band wavelengths were, linear transceiver or transponders that basically repeat a whole band of frequencies as opposed to a single frequency. And an inverting linear, which is the difference product, so it inverts everything. And one of the main things it will kind of compensate for Doppler shift, except for a geostationary satellite. Shouldn't.
Yeah, Faraday rotations.
Yeah. Transponder power, because it's a linear amplifier, you need to limit your power to the minimum needed so that you play fair with other users. LEO satellites most of them can do store and forward because their passes are so short. You don't have much time to make a connection. Pretty much send a message and wait for the other guy to see it. And Faraday rotation, because satellites are rotating, and you use a circularly polarized antenna. And